Now people on YouTube should be able to hear me as well. I don't know if it works or not. If somebody could check if you can hear me on YouTube, that would be great. Okay, great. Now you should be able to see me as well. So welcome everyone. My name is Paweł Żak. I am data engineering student at the second year at Gdańsk University of Technology, and I am the president of this students research group since this year. I'm very excited that you came, even after last week's problems with the Discord and the iPad. This students research group used to be called quantitative research, but this year we changed the logo and the name to Data Science Club. Yeah, does anyone have any questions before we begin? Okay, feel free to interrupt me at any point during the meeting. I'm obviously not an expert. I'm a second year student, so I'm here to learn as well, and I hope that you'll learn with me. So maybe I'll start with introducing my idea for this semester for our students research group. So we're going to have a few special guests who are professionals, unlike me, and every week or two, we'll see, I'll conduct this series, Data Science from Scratch, where I would like you all to participate actively. This won't be lectures. What I have in mind is what a student's research group is supposed to look like. So we learn together, we solve some problems together, and yeah, I'm here to learn as well. So if at any point I talk rubbish or you have, I don't know, your opinion or something like that, please interrupt me. And yeah, I think that's it. Let me just check the chat at Zoom. Okay, I can see it now. I didn't see it earlier. Hello, hello. Yeah. Okay, at this point I think that we can start with the, I don't know how to call it, the lecture, I guess. Okay. The camera seems to be frozen, isn't it? Yeah. But it should work now. Can you see everything clearly both on YouTube and on Zoom? Those of you who are on YouTube, I encourage you to come to Zoom, because you can ask questions here and interact with me, so I won't feel so lonely speaking to my computer. That's kind of weird. I'm not used to it yet. What I would like to begin with is to talk about data in general. Why do we even bother to care about data, and why do I and probably you study the thing that we study? So on the graph you can see that the amount of data at the moment is about 50 zettabytes, which is an incredible number. So zeta1 zeta. Sorry for my handwriting, but I do it with my mouse since the iPad thing didn't work last week. Maybe I'll borrow a graphical tablet from someone soon, or get one myself. Thank you. 1 zeta is 10 to the power of 21, so 1 zettabyte is 10 to the power of 21 bytes, which is billion of trillions, if I'm not mistaken. In comparison, for example, there is there is 1 zettabyte stars in the universe, and we have over 40 zettabytes of data at the moment on Earth. So that's pretty incredible, and as you can see on the graph, it's only going to grow exponentially. It's in 2025 we'll have up to 200 zettabytes. So yeah, that's great. That's great news for us, because if there's more data, there's more workplaces for us and more money. So yeah, we should be all thrilled about it. You probably often heard the term big data, and there are some misconceptions with that. So let me just. Okay, Damian. Yeah, thank you. What was I saying? Yeah, big data. What is big data? Big data. Damian, who used to be the president of this research group, once told me that big data is data that you can't process in Excel sheets. That's kind of a joke, but yeah, big data is data that you can't process on your computer, so you have to do it in parallel between a few different computers. These computers perform computations at the same time, so you get the result and you get it way faster. Yeah, so that's what big data is. Nothing more to say about it. So maybe yeah. So who is a data scientist? Data scientist is a person who uses data to answer questions, who are the questions which are asked by their employee, for example, or just a question that they think that is interesting. So data scientists are not necessarily great computer scientists, or they should be, but it's not about computer science and statistics and machine learning, maths, etc. It's about the ability to answer questions and to solve problems. Yeah, let's move to the next thing. Yeah, so here you can see few it's tasks that have to be done in order to process data. From the bottom, these are the tasks related with data, the list, and at the bottom, at the top, we have the thing that we would like to take out from our data, let's call it this way. On the red, you can see how different roles in companies, how responsibilities are divided between these people. But it's not necessarily true. For example, if these red arrows are correct, but only to big companies, very big companies. So, for example, in a startup, if a startup is looking for a data scientist, they are probably going to do all of these things instead of only this part in the middle. And in a very large company like Facebook, for example, or Google, these responsibilities could be divided even further because they have more money and more resources to employ employees. So as you can see, what data scientists do, maybe I'll talk about it later. As you can see on the right, there are engineers and scientists, and the difference between those two is that engineers are more specialized in the technical part, and scientists are more specialized in the science part, obviously. So the graph isn't quite complete because we have other roles that we could put in here. For example, we could have oh, that's big. Maybe I'll put it into full screen. We can have machine learning scientists who do, for example, this part right there, and the difference between a machine learning scientist and machine learning engineer would be the fact that machine learning scientist is focused on choosing the best model to the data that they have, and machine learning engineer would, for example, rewrite the code into C++ or other quick language. I can see a question. Where is statistics in this graph? So statistics is right here. All these people who, the data scientists and data analysts, use statistics to solve tasks that they are meant to solve. But not only statistics, and we'll get into that in more details in a second. Difference between machine learning scientist and machine learning engineer. Machine learning engineer is supposed to deploy the machine learning model into production. So, for example, implement it in C++ and implement it into an app, for example, like a recommendation system in Spotify. And data scientists won't do this. Data scientists will analyze data. On the next graph, here you can see how each of these roles, what are their responsibilities, and what portion of their time they spend on these individual tasks. I don't really agree with this graph that well. I think that data engineers don't spend that much time on business needs, but I'm obviously not a data engineer, and I could be wrong. Also, I would say that data scientists spend more time with business than it is suggested on this graph. So maybe I'll talk about great question, Damian, thank you. Let me get into the workflow of data scientist, if I can say so. I don't know if the workflow is a good word for it, but yeah. So huge companies like banks, for example, they gather a lot of data and they don't really know what to do with it. They hire people like data scientists and all these other roles to extract some information from the data. So, for example, if you go to the bank's site and you log onto your account and click around on the site, each of these clicks is registered by the bank and stored in the databases to extract information from it later. And what a data scientist would do is to analyze this. They would analyze this data in order to retrieve information from it. So machine learning engineers create algorithms based on data. Not really. From what I know, this mustn't be true, of course. Machine learning engineers rewrite the algorithm that data scientists and machine learning scientists choose earlier into more efficient languages than those that data scientists, programming languages, than those that data scientists and machine learning scientists do, use and not do. And they would implement it into the product itself. So, for example, yeah, as I said earlier, recommendation system on Spotify. Data scientists would analyze the data and choose the best model, and machine learning engineer would rewrite the model into rewrite the machine learning algorithm into a with faster, betterly performing language than Python or R, which we use for data science, and implement this algorithm into the final product. So they'll take care of this software engineering part of implementing the recommendation system to Spotify, for example. But I think that I'll explain it in more details in a second. Yeah, maybe someone have any other questions. Was my answer like good enough? Do you know what I meant? Okay, great. Moving forward, let's look in more detail into what a data scientist do. A data scientist, like let's say a project made by a data scientist would always start with communicating with the user, or who is a supervisor a supervisor in this case, and deeply understand the problem that they need to solve. That is the first point. So maybe I write those down so you have something to look at. Yeah, so firstly, we understand the problem that we need to solve. We, I don't know, are on meetings with the people in the company, and yeah, understand the problem. Then the second thing that we'd have to do is to gather data that would allow us to answer this question. So, for example, if you would like to determine which of our clients is supposed to get a loan, I'm talking about bank. then we would gather personal data about all of our clients. And this data can come from different sources. Companies, I think, don't really care where from the data is gathered, as long as it's legal and licensed properly. Yeah, maybe I'll write it down. Gather data or data. People say data or data. I don't know which one is correct. I think both, and it depends on the country where you live in, or whatever. If it's American English or maybe British English. Okay, thank you. You can also use your microphones, and I suggest you do that, because then I don't know how I won't feel so lonely. Data is British. Okay, that makes sense. Yeah, so we can gather data from like lots of different places, and I'll give you a few examples. For example, we can use the data from data. Oh, Jesus, that's not good. Maybe I'll draw it. From the database of our company, that would be the bank in this case. We can gather data from APIs. I won't go into detail what APIs are, but these are let's say software produced by some external company in order to give access to their data. For example, Spotify can create a Spotify has a Spotify API which you can access and get data that they are willing to share. There are also online repositories that we can get data from. I won't write the other words. For example, the Polish institution which is responsible for health shares data that they gather about COVID-19. And we can also web scrape data. What web scraping is, maybe in few brief sentences. So web scraping is basically extracting information from the HTML code that stands behind a website. So for example, maybe I'll show you. If we go to maybe let's Google dog and go to Wikipedia page. If we click inspect, we can see all the HTML code that was used to create this site. On this page we can see lots of data. Everything that is stored and visible for us on this page is in this HTML file. So all the text that we can see here, all the photos that are on the right, all the text from whole page is stored in this HTML file, and by web scraping we basically store this data in our environment, Python for example, and we try to extract information from it. This isn't the most efficient way of gathering data, as you may think, because it's just very time consuming, and if, for example, Wikipedia decides to change something about their page, the code isn't reproducible anymore, and we would have to scrape the data again. So after we gather our data, then we have to prepare it in some way. So let's say we gathered part of our data from web scraping, and the other part from API, and another part from the database. So now we have to gather all this data into I'm missing a word here. Into digestible format for us. So we would clean the data. That's a term that you hear a lot, because this is the part that data scientists spend most of their time on. What I mean by cleaning the data is that data comes in very different formats, and for example, an artist who's uploading songs to Spotify, if we worked at Spotify, can upload them in many different formats, and maybe no, that's a bad example. What cleaning data is transforming the data in a way that we would like it to be. So, for example, changing types. If we scrape the data from the web, all the information is going to be stored as strings. And data types in databases don't have to be in formats that we would like them to be as well. So, what I mean by cleaning the data is changing it into more digestible form. Yeah, we'll get into details when we actually do those things. So here we have step that is, I would call data preparation. And for example, we can clean and we can transform the data here. This is an O. Okay, moving on. Now is the time for our statistical skills. So Damian earlier asked, where is statistics in here? Here we will do, as a data scientist at this point of our process, we'll do explanatory data analysis. Yeah, so what explanatory data analysis, I should say data all the time, not data, whatever. What I mean by that is that we have to understand the data that we have. We have to do some graphs to understand, to see what are the standard deviations or whatever you want between all different columns of data that we have. Maybe I should also show you how such data may look like, because those of you who haven't touched data science or any sort of these things before may be confused when I say data. So data that data scientists analyze, let's say, comes in a format of tables, like Excel sheet. We would have indexes which start at 0 and go up to n, and we would have columns which are usually labeled with strings. So, for example, we would have a name here, or birth or whatever, and all these different attributes, and in each row there is one value of one type. Each column has one type. So for example, in name you would have strings. In birth we would have an object that is called date time. Yeah, so this is what I mean when I say data. So we gather data in different forms, we transform it into this digestible form of our tables, and then and clean it, set correct data types, handle missing values, etc. And now in explanatory data analysis, we would draw different graphs and do a bunch of statistics to understand our data well, and to be sure which columns represent what values. And in the next step, which is data modeling, let's say, that we know. Okay, so our endpoint. Oh, maybe I should start with that. At the end, as data scientists, we would like to create a model, machine learning model, that would predict our desired outcome. And not our desired outcome, but predict something based on this data. And what I mean by something is answer the question that we were supposed to answer at the beginning in the first step, where we had to understand the problem that a company had, and we had to deliver a solution. So at the end we have to deliver a solution which would be a machine learning model, for example, that would predict future values. I think it's a good place to mention difference between data analyst, and data scientist. Data analysts focus more on answering questions that can be answered based on our past data, and data analysts would stop on the process of explanatory data analysis, basically, where data scientists, their end product is usually predicting future values, or in time series data, or creating a model that categorizes data. For example, we can categorize our clients in terms of whether they should get a loan or not. Data analyst stops where the fun begins. Yeah, you could say so. I'm pretty sure that Mr. Carroll, for example, wouldn't agree with us, but with you and me. But yeah, that's pretty much correct. And data scientists are just data analysts who know more computer science and some algorithms that allow them to predict the future. I think that it's a good moment to have a 5-minute break. I would like to do breaks in these meetings in a sort of Pomodoro method, maybe. So after 20 few minutes, we'll do a short break to betterly focus later. So yeah, let's have a 5-minute break. See you in a while. I have to go to the bathroom as well. If you have any questions so far, if anything is not clear, please ask. And if you don't feel comfortable in asking this question in English, you can also ask it in Polish. That's not a problem. Okay. Let's continue. Yeah, so in explanatory data analysis, we would find patterns in data. We did some helper visualizations. And we would try to understand each feature of the data set. I hope it's clear. If not, please ask questions. Moving on, we would get to the final step, not final, but all the one that everyone is waiting for, including the data scientists analyzing the data. We would do data modeling. And what I mean by that is we would choose features that we find significant. So we would do so-called, it's not data reduction. We would also do data dimension reduction, for example. So what dimension reduction is, we try to represent different columns with one column. So for example, so we would gather a few features. A feature is a column, basically. So we would gather a few features into one. We would like to do so because it's more digestible for the machine learning algorithm that we'll write in this step as well. Not write, we would just use it from a library that is available for us. So dimension reduction and feature selection. Yes? So there are special algorithms like PCA, for example, if I'm not mistaken. These algorithms would so the easiest the dimension reduction, which is not very effective, but we could do such thing, is, for example, take a mean of two features. So we have feature A, feature B, they have some values, and we take mean of each of the rows and store it in a column C, so that the column C represents both column A and column B. Is that clear? We shouldn't worry at this point. How do we do those things? We'll get to it in future workshops. Basically, there are algorithms that we can use to do such things. Another question. Does dimension reduction also include reducing the number of observations? Not necessarily. We usually wouldn't like to reduce the number of observations in the first place, because the more information we have, the better model we can create. So yeah, the step of reducing number of observations would be in data preparation, in data cleaning. We would, for example, delete rows where there's more than, I don't know, 20% of null values. Null is basically a value that we don't have. I think it's based on observations, and its goal is to create a field that is saying something about those observations. Yeah, that's correct. So we take two columns and we try to represent them with one. Do you think that understanding maths behind all these machine learning algorithms is essential? Do programming skills and knowledge of how to use machine learning libraries is enough to to be a successful data scientist? The libraries that we use, for example, in Python and R, are just tools. Data scientists, as I said at the beginning, are not computer scientists. We more care about the maths that is behind the algorithm than the pure implementation. Implementation is already done by someone. That's in the first, yeah. So implementation is done by somebody else, and we only use libraries created by those peoples. And if we know what we would like to do, which algorithm, for example, we would like to use, it is very easy to Google how to use it in a language of choice, or R or Python or even Excel. Yeah, I think you can do some machine learning in Excel if you really want to. So, as a data scientist, you have to know the maths that is lying behind the algorithms. Maybe not necessarily all the maths. It is important to understand it, and the better you understand it, the better you can use those algorithms. But the most important thing, in my opinion, is to understand what is the purpose of this algorithm, of each individual algorithm, machine learning algorithm, and how to use it and when we should use it. I'd like to stop here and briefly introduce you to machine learning, because I'm sure that there are a few of us who don't know what machine learning is. So you probably heard the term artificial intelligence, AI. It is a really big word nowadays, and people even say that humanity is going to collapse because of artificial intelligence. I personally don't believe it. Knowing few machine learning algorithms, I can say that AI is stupid. The people are clever, not the computers. Inside of AI, we have an area of machine learning. So not all AI is machine learning. These are not the same things. Machine learning are the algorithm that learned computer that instruct the computer to learn and find patterns in data in order to retrieve some informations that we don't know. For example, categorization. So we first feed this algorithm with lots of data. The more the better. And then the algorithm is able to predict values that it hadn't seen before. That's what machine learning is. And AI on its own is a very broad term. So as I understand it, AI is basically anything that any situation where a computer or something like that mimics an intelligent behavior. So, for example, if we specify every case of, let's say, Tetris game, and we write an algorithm that takes into account every possible combination of Tetris moves, and then we run this program and the computer plays Tetris on itself, is also AI. So if we explicitly say the computer what to do and it does something that seems intelligent, it is also called AI. Machine learning, on the other hand, are just algorithms and lots of maths behind them that allow us to predict something, for example, or categorize our data or whatever. And inside machine learning, we have a field of deep learning. Maybe I should color this. Maybe not. Let's do it like that. Oh, you can't see anything. Doesn't matter. What deep learning is, these are machine learning algorithms inspired by the network of neurons in our brain. So yeah, these algorithms are very computationally intensive. But in many cases more effective and allow us to solve problems that couldn't have been solved without them, like autonomous cars, for example. Yeah. So that's what machine learning is, and in this step of data modeling, we would also choose the best algorithm for our data and apply it. So let's just call it ML. Next step in the process in the company that we work in would be to communicate our results to the businessmen, so let's call it this way, who are not familiar with what we do at all. So this can be the most frustrating and difficult point of the whole process for many people. You have to basically communicate your findings in the simplest possible way so that these people hopefully will understand what you did and will allow you to implement it into the system. And so how should I call it? Let's say that visualization, this is an A, and communication. And the last step would be to deploy it into production, so actually implement it into the end product. So to recap, maybe let's go through all of it again. So we have to firstly understand the problem, then gather the data, then prepare the data, then understand it, create a model, communicate our results, and deploy it to the commercial use. So that basically is what data scientists do. And now I would like to talk more about data engineers. This is the field that I'm least specialized in, let's say. Lately, I got more into data engineering, and I try to do it myself, and I learn about it. But I'm not an expert. We have, I think, on Zoom somebody who would be able to correct me at any point if I'm wrong. It's like the purpose is not to introduce you to some let's say software that data engineers use, but I would like you to just understand what data engineering is. I study data engineering at the Gdańsk University of Technology, and sometimes I'm under the impression that most of employees and most of students don't know what data engineering is. So I think it's it's important that at least you know it. Do you have any questions concerning the previous part about data science? I think not. Maybe on YouTube. Nope. Okay. Thank you for your questions. It's really important that you ask those, because I don't know if I'm communicating all these things in an understandable way. Moving on, let's imagine that we talked about Spotify earlier, so let's imagine that we work at Spotify, and let's visualize the process of... Oh, I see a question. Do you think that cloud technologies like AutoML and data fusion can make managers replace data scientists in small and medium-sized companies, and as a result significantly decrease demand for data science? So as it comes to my personal opinion, it is very possible, I think. As far as I know, the main disadvantages of these tools at the moment, maybe for those of you who don't know what AutoML, for example, is, these are cloud solutions that allow us to basically eliminate the process of choosing the best model and the best parameters for the model. It does it for us, so we don't have to do machine learning by ourselves. This is a very interesting topic. That's a great question. It is very hard to predict, at least for me, but I can see that mostly, maybe not mostly, but especially small and medium-sized companies would in the future use those tools not to waste their resources on data scientists. Yeah, it is possible. But it doesn't mean that we shouldn't learn data science, because first of all, it won't happen probably in the near future, because these these tools are very expensive and resource exhaustive. That's why we don't have it everywhere yet. And I don't see it getting cheap and accessible to everyone in the near future. Yeah. 1 second. I need to find something. Okay, so maybe I'll do a short introduction, and then we'll have another 5-minute break. So what I would like to show you now is the process of building a recommendation algorithm for songs in Spotify, for example. Those of you who use Spotify probably are aware of the playlist Discover Weekly. Other music providers, let's call them, probably have their equivalents of that. I personally nowadays listen mostly to this playlist, because it works. These algorithms that stand behind it work great. So it all starts with artists in case of Spotify. So we have artists who post their songs and personal information about them into the system. Yeah, I hope that you appreciate my drawing. Thank you very much. I did my best. We also have the user. Let's give him some headphones. Great. And yeah, these are main sources of our data, of the data that we use in order to predict what would such user like to listen to. We can obviously use other sources of data that we talked about earlier. We can also buy data from different companies and data vendors, I think these people are called. I'm not sure. Please correct me if I'm wrong. So let's write, oh, this is small. I will make it bigger. Yeah, so those together provide us with data that we will need to create such predictions. And John Lennon, I didn't mean to draw John Lennon, but yeah, it could be. Let's have another break now, 5 minutes, so we'll be back at 8:40.